things can get a tiny bit more complicated when we deal with integrands that are more complicated. So in this case, we've got the integral from 1 to infinity of x times e to the negative x dx. As before, we're going to proceed by doing the limit as b goes to infinity of the integral of 1 to b of x times e to the negative x dx. And one thing that you should have noticed from our interesting lessons from last week is that this is an ideal situation to use integration by parts because we have a product of two different types of functions inside the integral. So we make u equal to x, du equal to dx, dv is e to the negative x dx, which makes v negative e to the negative x. That's because of the chain rule. When we evaluate this, I'm kind of doing this off to the side in blue here, but when we evaluate this particular antiderivative, we get negative x e to the negative x minus the integral of negative e to the negative x dx. That's just using our integration by parts formula. And then we evaluate the integral just as we would normally do. So the antiderivative is negative x e to the negative x minus e to the negative x plus c. A lot of negatives. Now, as we go back to the top, the original problem, we see that we can then substitute our new antiderivative, which I will write as negative x over e to the x, because we have a negative exponent, minus 1 over e to the x, as the integral goes from 1 to b. It's missing that bottom limit there. Now we get to a point where we want to actually evaluate this limit. So we plug in our upper limit, b, and we get negative b over e to the b minus 1 over e to the b. And we still keep the limit as b goes to infinity. In addition, we plug in our lower limit, and we get negative 1 over e minus 1 over e. Looking at these limits individually, we see that we have an exponential on the bottom, which overpowers our polynomial. In both circumstances, in fact. So the limit as b goes to infinity of this entire expression will just be 0. And so we're left with whatever we had when we plugged in 1 as our limit, which ends up being negative 2 over e. Since we're subtracting due to the FTC, the final answer ends up being 2 over e. Integration by parts was very useful in this particular problem because it allowed us to evaluate the integral that was in question. The techniques that we've used in the last couple of weeks, namely substitution, integration by parts, and partial fractions, will be very useful, and so it'll be helpful for you to understand when to use what technique in what circumstance.